Welcome to the video lecture series of Project Development and Resource Management. This is an MTech subject, course code Mce301, contact hour 4, credit 4. This is one of the subject of third semester in MTech of Electronics and Communication Engineering. Myself, Dr. Shunipa Roy, Assistant Professor of Electronics and Communication Engineering Department, Guru Nanak Institute of Technology. This lecture is from Module 1. Module 1 consists of meaning of research, objective, motivation and types of research, research process, what we have covered in our earlier lectures. And also there are the things that is sampling, different types of sampling, testing of hypothesis, chi-square test. Different types of statistical techniques are there, among which we have covered introduction to statistics in our earlier lecture. In this lecture, we will cover the central tendency, sample, population. So moving to our next slide, this is the lesson plan. In this particular lecture, we will cover the central tendency and different types of data. What are the different types of data we use in statistical analysis? This is lecture 5. So, variables. The way of presenting data in statistics is called variables. A variable is a characteristic or condition that can change or take on different values. Most research begins with a general question about the relationship between two variables for a specific group of individuals. So moving to our next slide. What is population? Population is nothing but the whole set of data, a group of individuals, whole set of data, whatever data can be collected or whatever data are having in the market is called population. This is the bulk. Bulk data is called population. For example, a researcher may be interested in the relation between class size and academic performance for the population of third grade children. So this class size is variable 1 and academic performance is variable 2, and the third grade children is the entire population for the data. Sample is nothing but a small portion of population is called sample. Usually population are so large that a researcher cannot examine the entire group. Therefore, a sample is selected to represent the population in a research study. The goal is to use the results obtained from the sample to help answer questions about the population. Say there is a full sack of rice. Among it, we have collected a handful of rice. So this handful of rice is called sample, and the whole sack of rice is called the population. So population is the bulk data and sample is the sampled data. I hope the concept is clear between sample and population. So here we can see the cycle. The population, all of the individuals of interest. From this arrow shows the sample is selected from the population. So next the arrow, the sample, the individuals selected to participate in the research study. And the final is the result from the sample are generalized to the population. Whatever data we are having from the sample, we can generalize it for the entire population. Otherwise, it is not possible to collect data from each and every individual. So moving to our next slide. Here we can see the types of variables. Variables can be classified as discrete or continuous. Discrete variables such as class size consist of indivisible categories, and continuous variables such as time or weight are infinitely divisible category into whatever units a researcher may choose. For example, time can be measured to the nearest minute, second, half second, etc. So, continuous variable, time is continuous variable, and indivisible category of variable is called discrete variable. That is class 3, class 4, class 5, whatever. So moving to our next slide, real limits. To define the units for a continuous variable, a researcher must use real limits, which are boundaries located exactly halfway between adjacent categories. I repeat, real limit is nothing but we can define it as units for a continuous variable. A researcher must use real limits, which are boundaries located exactly halfway between adjacent categories. So moving to the next slide, here we can see the topic measuring variable. So what is measuring variable? To establish relationships between variables, researchers must establish relationship between variables, researchers must observe the variables and record their observations. This requires that the variables be measured. So, the process of measuring a variable requires a set of categories called scale of measurement, and a process that classifies each individual into one category. So, scale of measurement actually classifies each individual into one category. So, types of variable. Now, what are the types of variable? We can simply explain that variable can be classified as continuous variable and categorical variable. So continuous variable, that is continuous in nature. There is no discrete steps involved or there is no breaks involved. Now, categorical variable. Categorical variable can be classified as nominal variable and ordinal variable. So what is nominal variable? What is ordinal variable? It can be understood better if we follow this table. Here we can see a data set. There are 10 data sets. So there are 4 additional columns, that is marks, teacher feedback, gender, year of study. So marks is random in nature. The value is random in nature, where you can conclude that which one is continuous variable. Obviously, these marks are the continuous variable because any of the value it can take. Now, if we go to the categorical variable are of 2 types, that is ordinal variable and nominal variable. Nominal variable and ordinal variable. So what is nominal variable? See, if we go to the gender is male, female, male, female, male, female. Okay. Now, year of study. If we go to year of study, we will find senior, mid-year, junior, mid-year, junior. If you go through it very minutely, you can find that gender, male, female, has no order. It can only define either it is male or female. There is no order. But if you minutely observe year of study, you will find senior, mid-year, junior. There is an order. Right? Now, similarly, if you go to the teacher feedback, you can also find that good, bad, excellent. There is an order. Say excellent is 3, good is 2, bad is 1. Similarly, year of study senior may be upper senior may be 6 to 7 to 10, mid-year may be 3 to 5, and junior is 1 and 2. So there is an order. So these are the teacher feedback and year of study are the ordinal variable, whereas gender is the nominal variable and marks is continuous variable. Hope the concept is clear to everybody. Which one is nominal variable, which one is ordinal variable, and which one is continuous variable. And nominal and ordinal as a whole called categorical variable. So what is, now we will look to central tendency. What is central tendency? The numerical value of an observation around which most numerical values of other observation in the data set show a tendency numerical value of an observation around which most numerical values of other observation in the data set show a tendency to cluster or group, then this is called central tendency. The extent to which numerical values are dispersed around the central value called variation. And the extent to departure of numerical values from symmetrical distribution around the central value called skewness. So I repeat the central tendency. The numerical value of an observation around which most numerical values of other observations in the data set show a tendency to cluster or group called central tendency. And the extent to which numerical values are dispersed around the central value called variation. So these three properties, central tendency, variation, and skewness or shape, may be used to extract and summarize major features of the data set by the application of certain statistical methods called descriptive measures or summary measures. There are three types of descriptive measures. First one is measures of central tendency. Second one is measures of dispersion or variation. Third one is measure of symmetry, that is skewness. So the term central tendency was coined because observations in most data sets show a distinct tendency to group or cluster around the value of an observation located somewhere in the middle of all observations. It is necessary to identify or calculate the central value to describe or project the characteristics of the entire data set. This descriptive value is the measure of the central tendency or location, and methods of computing this central value are called measures of central tendency. So I repeat, the term central tendency was coined because observations in most data sets show a distinct tendency to group around the value of observation. That is located near the middle of the observation. And it is necessary to identify this typical central value to describe the characteristics of the entire data. This descriptive value is the measure of the central tendency or location, and methods of computing this central value are called measures of central tendency. And if the descriptive summary measures are computed using data samples, Next, we see the central tendency. What does it mean? We can better understand it by observing mean, median, mode, and range. These all are facilitating the central tendency. So what is mean, what is median, what is mode, and what is range? Let us go to our next slide. So mean is computed by adding all of the numbers in the data together and dividing by the number elements contained in the data set. So mean is computed by adding all the numbers in the data together and dividing by the number of elements contained in the data set. Here, this is an example. This is the data set 2593547. Number of elements in data set are 7. So the mean is just simply add these numbers and divide it by 7. That is number of elements in the data set. That is coming 5. So the mean or averaging is 5. Next, our matter of concern is median. The median of a data set is dependent on whether the number of elements in the data set is even or odd. So first reorder the data set from the smallest to the largest and mark off high and low values until you reach the middle. If there are 2 middles, then add them and divide it by 2. If we take an example, it will be more clear to us. Say this is a data set. This is odd number of elements are there. 2593547. So 7 elements are there. First, we have to reorder the data set. That is 2, 3, 4, 5, 5, 7, 9. Next, as there are 7 elements, so the middle one is the 4th element. That is 1, 2, 3, 4. 4th element. This one is the middle one element, 4th element. So median is 5. As the number of elements are odd, the process is simple. But what will happen if the number of elements are even? So moving to our next slide, here we have 6 elements, 259354. Just reorder the data set 2, 3, 4, 5, 5, 9. So here we can find 4 middle values, that is 4 and 5. So how to find median? To find median, just add 2 middle values, 4 and 5, then divide it by 2. It is becoming 4.5. So for even number of elements, just add 2 mid values and divide it by 2. Here it is coming 4.5. So for this particular data set, the median is 4.5. Now the point mode. Mode for a data set is the element that occurs most often. So from this line, we can conclude that most is nothing but the frequency of a data set. It is not uncommon for a data set to have more than one mode. In that case, it is called bimodal. Bimodal data set, unimodal and bimodal data set. This happens when 2 or more elements occur with equal frequency in the data set. So moving to our next slide, data set is 2593547. So number of elements are 7. So here we can see 2 is occurring only once, 9 occurring only once, 3 occurring only once, 4 occurring only once, 7 occurring only once, only 5 occurring twice. So the mode of this data is 5. Now, if we go for next data set, that is 2523547. Here we can see 2 is occurring twice, 5 is occurring twice, 3 is occurring once, 4 is occurring once, 7 is occurring once. So the frequency 2 is occurring twice, 5 is occurring twice. So this is the bimodal data set. The mode is 2, that is 2 and 5. So this is called bimodal data set. Now the term range. The range for a data set is the difference between the largest value and the smallest value contained in the data set. And for that, we have to reorder the data from smallest to largest, then subtract the first element from the last element. Let us have an example. So here we can see that say here is the number 2, 4, 5, 7, 9. So the range would be, range is last number minus first number, that is 9 minus 2. 9 minus 2, that is equals to 7. So the range is 7. So moving to our next slide. Before moving to our next slide, we once reconsider what are the objectives of averaging. Actually, it is useful to extract and summarize the characteristics of the entire data set in a precise form. For example, it is difficult to understand individual families' need for water during summer. Therefore, knowledge of the average quantity of water needed for the entire population will help the government in planning for water resources. Such an average represents the entire data set and it facilitates comparison between two or more data sets also. Such comparison can be made either at a point of time or over a period of time. It offers a base for computing variations. Other measures such as dispersion, skewness, that help in many other phases of statistical analysis. And what are the requisites for measuring the central tendency? Pardon. The following are the few requirements to be satisfied by an averaging central tendency. The first one is it should be rigidly defined. Second one is it should be based on all the observations. It should be easy to understand and calculate. And the next point is it should have sampling ability and it should be capable of further algebraic treatment. And it should not be unduly affected by extreme observation. And we have learned the measures of central tendency here. That is averaging. Averaging are of two kinds, that direct method and alternate method. We will learn this in our next lecture. So descriptive statistics, already we have learned in our earlier lecture that descriptive statistics are methods for organizing and summarizing data. For example, tablets or graphs are used to organize data, and descriptive values such as the average score are used to summarize data. A descriptive value for a population is called parameter, and for a sample it is called sample statistics or simple statistics. Inferential statistics are methods of using sample data to make general conclusion about the population. So when the population is very large, it is not possible to collect the data from each and every corner of the population, and in that case sample statistics is very much effective. So sampling error. What is sample error? The discrepancy between a sample statistics and its population parameter is called sampling error. Defining and measuring sampling error is a large part of inferential statistics, and there are so many methods involved also. So we will study in our next lecture in detail about the sampling error. So this is the reading material. If there is any question, please feel free to ask me to this email ID. Thank you very much.